So this is the chapter 2 review, and we'll continue from question 16 and on. And so I want to remind you that you need to open this document where you have the System International base units, temperature equations, prefixes for the metric system, and then the US to metric equivalencies at the bottom in the pink table. So have this open. So we were left, we had done up to question 15, and so we'll start with question 16. So the following information is found on a 12-ounce box of crackers. And we have nutritional information. Serving size is 0.50 ounces or 6 crackers. So I advise you to rewrite this as an equality because, this is an equality that says 6 crackers. 6 crackers are equal to 0.50 ounces. You want to see it like this as an equality. So my advice is to rewrite it like that as an equality. Same with fat. You know that it's 5 grams of fat per serving. So rewrite it as an equality. So 1 serving is equal 4 grams of fat. If you see it like this, you see that it can be used as a conversion factor. And then for the sodium, we have 1 serving is equal to 140 milligrams of sodium. But we can just put Na, sodium. So you want to read these as equalities and then realize that you can use them as conversion factors. So first question, if a box of crackers has a net weight, contents only of 8 ounces, about how many crackers are in the box? So how many crackers in the box? That's what we want. And we have what is given here is the 8 ounces of crackers. The box is 12 ounces. But only 8 ounces are for the crackers only, right? Because this 12 ounce box of crackers, it's, the packaging plus the crackers. So crackers only, it's 8 ounces of crackers, and you want to find, how many crackers. So number of crackers. So the equality we can use, so because we have number of crackers versus ounces of crackers, it looks like we can use the first equality here that says 6 crackers equals 0.50 ounces. Oops. Right? That will allow us to change mass of crackers in ounces into number of crackers. So we are ready to do the calculation already because here there is only one conversion necessary because we can already relate the ounces of crackers to number of crackers using this equality. So when you're ready to do the calculation, always starts with the given amount, and here it's 8.0 ounces of crackers, crackers. And because it's just a simple unit here, then in the denominator, it's going to be a 1, right? There's nothing in the denominator here. You have a simple unit of ounces of crackers. So always start with the given amount in the numerator. And then you will multiply by the conversion factor. And the conversion factor is obtained from the equality here. And want to cancel the starting unit. And here the starting unit are ounces of crackers. So you want the 0.50 ounces to go in the denominator because you want to be able to cancel ounces of crackers here. So they will cancel because one is in the numerator, one is in the denominator. And then we have 0.50 ounces for 6 crackers. So we can write 6 crackers on top. And So the leftover unit will be the number of crackers. So we can write the unit there. Next, in your calculator, you take 8 and then multiply by 6 and then divide by 0.50. And it's 96. That's the calculator answer. So we need to pay attention to sig figs. Here in the given amount 8.0, we have 2 sig figs. In the 0.50 ounces, we have 2 sig figs. The 5 and the 0 to the right is significant. And 6 crackers, it's an exact number. Remember how exact number are obtained from counting things or by definition. And here it's obtained by counting the number of crackers, and it's not limiting the number of sig figs. So then we are limited by 2 sig figs from the 2 given amount of ounces there. So we keep the 9 and the 6 crackers. So that's 96 crackers in a box. That's a lot. Question B, if you ate 10 crackers, how many ounces of fat are you consuming? So what is given here? 10 crackers, right? We have 10 crackers and we want to know ounces of fat. You know, ounces of fat you are consuming when you're eating 10 crackers. So we do not have a direct relationship between a number of crackers and ounces of fat, because we have crackers 2 ounces, but that's ounces of crackers, right? This is of crackers. So we can start by doing, you know, a conversion from crackers to ounces of crackers. So we can use this equality there. Then we will, and so let's write here what we have. Crackers will be the first unit. Then we will change that to ounces of crackers. But we want ounces of fat. And for the fat, the relationship we have is 4 grams of fat per serving. So, and the serving size here, it says, so I should add here, that's actually also 1 serving, right? Here you can add that it's 1 serving. So actually, it makes more sense to change the crackers to the serving. We don't really need the number of ounces. So let's do that. Let's do actually crackers to serving, because the fats here are related to serving. So then we can use the servings to grams of fat. So servings to grams of fat, but we want ounces of fat, not, you know, so we will have grams of fat, but we want ounces of fat. And for this, you need to convert the grams into ounces, and that's a relationship you will find in the table of, you know, conversions between US and metric units. And so that's going to be in the mass row, and because it's between grams and ounces, it's a US metric unit here. So you need to look at this last column. And here you can see the relationship between ounces and fat. We have 1 ounce is 28.35 grams. So you want to use that. So let's write it down here. 1 ounce is 28.35 grams. So it looks like we have everything this way, right? So let's check that. From crackers, we will change the number of crackers to number of servings. Then from, you know, using this equality. Then once we have the servings, we can change them to grams of fat using this equality here. And once we have the grams of fat, we can then change them to ounces of fat. So the roadmap looks like this, right? And we have, you know, 3 arrows, which means you will need to use 3 equalities. So let's put that into the, you know, calculation here. So always start the calculation with the given amount. So we want to use 10 crackers here in the numerator and start the calculation with that. So we have 10 crackers and that's a single unit. So there's nothing in the denominator. So you can put a 1 in the denominator. The given amount is always put in the numerator. Then you will multiply by, 3 conversion factors because we have 3 conversions to do. The first conversion factor will change the crackers to serving, and we will use this equality here. So we want to cancel crackers, units of crackers there, number of crackers. So we'll put the 6 crackers on the bottom and the 1 serving on top. Next, we want to cancel the unit of serving, right? Because this is something we don't need to keep. So it's an intermediate unit and it's going to be 1 serving. And remember here, we need to change the serving to grams of fat using this equality. So 1 serving is 4 grams of fat. That's on the numerator. Servings cancel and we have grams of fat at that point. But we want ounces of fat. And so we will change the ounces into the grams into ounces. And so we will have the 28.35 grams on the bottom here because we have grams of fat on the numerator in the previous conversion factor. And here, then we need the grams in the numerator, in the denominator, sorry. And then the 1 ounce on top. And so it's 1 ounce of fat here. Let's specify. So this way we see crackers, the units of crackers cancel, the units of servings cancel, the grams of fat cancel, and we are left with ounces of fat. So we know it's the final unit there. We can write it down. Next, you want to do the calculation on your calculator. And so for this, you do. I like to usually multiply the numerators together and then divide by each denominator. So that's going to be 10 multiplied by 1 serving, multiplied by 4 grams of fat, and multiplied by 1 ounce. So 10 times 4, and then divided by 6 crackers, and divided again by 28.35 grams. The calculator answer is 0.235, etc. Again, we need to pay attention to the number of sig figs. So remember things like 10 crackers or 6 crackers or 1 serving, all of these are exact numbers, right? They are from counting a number of things. So they do not limit the number of significant figures. The 4 gram, however, was given. 4 grams of fat is measured for 1 serving. So that's only 1 sig fig here. The 1 ounce of fat is, this is an equality. So this is given. I mean, it's for exactly 1 ounce of fat, you get this number of grams. And so that's the measured value. So here we have 4 sig figs. This is another exact number here. The 1 ounce of fat is exact. So the limiting number of sig figs comes from the 4 grams of fat, and it's only 1 sig fig. So we need to keep it only 1 to 1 sig fig. So it's going to be 0.2 because what comes after the 2 is a 3. So you round down to a 2, and that's ounces of fat. So let me try to put this all in one line like this. So that's the answer to question B. So let's move on to question C. At the factory, how many grams of sodium are used to prepare 50 boxes of crackers? And 50 here, it specifies it's exact to the ones because there is the dot. So it's 50 with 2 significant figures. So how many grams of sodium? And here we have milligrams of sodium. So we know we will be using this. So let's copy that. We will be using the fact that we have 140 milligrams of sodium per serving. But here it's asking for grams of sodium. So we will need to change the milligrams into grams. So let's look at the milli prefix. The milli prefix, so the way to use this table is to say 1 milli, and that's grams for us here. The base unit is the gram. So 1 milligram is 0.001 gram. So let's write this equality. 1 milligram equals 0.001 gram. So this will allow us to change the milligrams of sodium to grams. But we need to go to servings from the 50 boxes here, right? Let's see, do we have an information like that? Serving versus box. It's so the serving size, so it's a we know it's so here we see that a box of crackers has a net weight of content only of 8 ounces, which means 8 ounces of crackers corresponds to 1 box. And then we know the number of serving for the mass of crackers in ounces. So let's use this one. We will also use this equivalence. You know, ounces of crackers to serving. This will relate servings to ounces of crackers. And then we know that a box of crackers has a weight of 8 ounces. So let me copy that. And here we will use the fact that 1 box is equal to 8 ounces of crackers, right? Content only. So that means the roadmap will look like this. So because, you know, I should have started by saying that the given amount is 50 boxes, right? 50 boxes of crackers. So we start with 50 boxes of crackers. So let's write the roadmap now because we need it, right? There's a lot of conversions here. So we start from boxes, 50 boxes of crackers. From the boxes of crackers, we can convert to ounces of crackers. So ounces of crackers. And just write this like that to keep space. From the ounces of crackers, we know the amount of serving. So serving. From the serving, we know the milligrams of sodium. So milligrams of sodium. And then from the milligrams of sodium, we can get the grams of sodium. And that's what the question was asking. How many grams of sodium are used to prepare 50 boxes of crackers? So we have a lot of conversions here, and we have, you know, 1 arrow, 2 arrow, 3, 4, and we do have, you know, 4 equalities here. So we are all set. We can start and write the full calculation. So you always start the calculation with the given amount, and here it's 50 boxes. So you put 50 in the numerator, and that's boxes. So we have 50 boxes of crackers and nothing in the denominator, right? Always put the given amount in the numerator. Then you multiply by all the conversion factors. You want to cancel units of boxes. So for the next conversion factor, you want to use the equivalence that has the box unit. So, and you want to put the box on the bottom here because this way you can cancel the units of boxes. So on top, it's going to be 8.0 ounces of crackers. Then at that point, you want to cancel ounces of crackers. And we know how to relate ounces of crackers to serving. So we will have 1 serving on top here. And then the ounces of crackers on the bottom, because you want to cancel the units of ounces. Let me make this bigger so there's no issues seeing that. Next, so you've canceled units of ounces. Next, you want to cancel the units of serving. So you want the serving in the denominator of the next conversion factor. And we will use the fact that there is 140 milligrams of sodium in one serving. So one serving, 140 milligrams of sodium. And finally, so servings cancel. Finally, we want to change the milligrams into grams. So you want the milligrams, 1 milligram on the bottom here, and it's 0.001 gram of sodium on top. So we are ready to, so if you check, because you always want to check if possible. If you check, you can sell boxes, yes, ounces of crackers, servings, milligrams of sodium, milligrams. And you're staying with grams of sodium. So the unit left will be grams of sodium. So let's do the calculation in the calculator. So we start with 50 multiplied by 8.0 multiplied by one serving, multiplied by 140 milligrams, and multiplied by 0.001 gram. That's everything in the numerator. And then divided, and divided, you only need to divide by 0.50. The rest are ones. Divided by 0.50. Equal, that's the grams of sodium. So let's see. We need now to pay attention to significant figures. So the 50 box, as I said earlier, has two sig figs. The 8.0 ounces, two sig figs. You know, the one box is exact, one serving is exact, one serving is exact. I want to say that this is all exact. This is by definition, 1 milligram equals 0.01 gram. That's by definition, and because of that, this is considered exact. So here, two sig figs in 0.50 ounces of crackers, because that's measured. And one serving has 140 milligrams of sodium, that's also measured. And here there is again two sig figs because the 0 is not significant. There is no decimal point to make it significant. So we said two sig figs, right? Two sig figs here, two sig figs there, two sig figs here, two sig figs there. So this will have to be rounded to two sig figs. So we keep the 100, the 10, and the 2 after that will become a 0, right? Grams of sodium. So rounded, it's looking like this. Let me put that inside. Like that. Okay. So let me specify that all measurements are given to two sig figs, right? The rest are exact numbers. So question 17, you are driving at 65 miles per hour. So let me emphasize mph means miles per hour. And you take your eyes off the road just for a second. How many feet do you travel in this time? That's an interesting question, right? It tells you, you know, how much likely you are to hit something if just suddenly there was something in front of you if you drive at that speed. So what is the given here? The given is the 65 mph. And let me emphasize that this is 65 miles per hour. Another way to write this is 65 miles slash hour, right? Because miles per hour means it's a number of miles you make in 1 hour. So you can also see it as, you know, 65 miles equals an hour. It can also be written as an equality. But here it will be our given amount. So for once, the given amount will have a denominator with a unit. because here you always start your given calculation with the given amount. So, 65, you will have 65 miles here per hour on the bottom. Okay, so just a heads up here. So we want to change that, and let me write. What do we want? We want this. How many feet? So we want feet. Do you travel in this time? And the time is just a second. So feet per second. So we want to change that into feet per seconds. So we will need to change the miles into feet. And at the same time, we will need to change the hours into seconds, right? And we know that we will need to go through minutes. So from hours to seconds to minutes, right? We will do that in one calculation, but you will need, different conversion factors for the numerator and the denominator. So as I said, you put the given amount, first in the numerator and with the per hour in the denominator. But let's collect all the equalities first. So we need to change the miles into feet. Let's see, hopefully we have an equality that relates them directly. So it's a unit of length. So you want to look at the first row here. And feet to miles, it's both US units. So you want to look at the first column. So in this box then, and then miles per feet here. 1 mile is 5,280 feet. So that's what we need. 1 mile equals 5,280 feet. And it was specified that it's exactly this. So 5,280. Change hours to minutes and seconds. So you know that 1 hour is equal to 60 minutes. And then we know that 1 minute is equal to 60 seconds. So, and we're all set. We have what we need to convert hours to minutes, minutes to seconds, and miles to feet. So only 3 conversion factors are needed here. So we place the given amount in the numerator, 65 miles, and then per hour goes in the denominator. Next, you have to think about this in 2 steps, right? First, you want to change the miles into feet. And because you have the miles in the numerator, you want the miles in the denominator here. And the relationship is 1 mile here. And so the 5,280 feet will go in the numerator. So this way we change the miles into feet, and we are done for that one, for that unit. So in the end, we will get feet, right? Now we need to change the hour, and it's in the denominator. So you have to be careful, it's in the denominator. So you want to cancel the unit by putting it in the numerator in the next conversion factor. So you want the hour here in the numerator, and it's going to be 1 hour is 60 minutes. 1 hour is 60 minutes. So this way we cancel the hours, we get per minute, but we want per seconds. So in the next conversion factor, you want to cancel the units of minutes. So minutes will go here, and it's 1 minute is equal to 60 seconds. So the symbol for seconds is just S. So this way we cancel the units of minutes, and we're left into seconds. So it's going to be feet. And so let me write this properly. It's going to be feet per second, and that's what we want, right? Because the miles cancel, the hours cancel, and the minutes cancel. And we're left with feet per second. Let's do the calculation. So on the calculator, you do 65 times 5,280 times 1 and divided by 60 minutes and divided again by 60 seconds. Or you could divide by 3,600 if you multiply 60 by 60 first. So is it correct here? So 95 feet, that sounds a lot, right? So we need to think sig figs here. So 1 minute is exactly 60 seconds. That's by definition. By definition, 1 hour is 60 minutes. That's also by definition. So all of these are exact numbers. 1 mile by definition is equal to 5,280 feet, and that's measured. So the 1 mile is exact, but the feet are measured. So we have 4 sig figs there. And the miles per hour, so the per hour is exact, and 65, there is 2 sig figs there. So we are limited to 2 sig figs because of the 65. So we want to keep the 9 and the 5, and that's it. That's 2 sig figs. And then we need the unit of feet per second. Well, when you think about it, it's 95 feet, in 1 second. So that's a long distance. If you think of, if you have an obstacle, you will definitely hit it. So you don't want to have your eyes off the road even for just a second. Question 18. The boiling point of nitrogen is negative 196 degrees Celsius. What is the temperature in degrees Fahrenheit? So notice how it's a very low temperature in degrees Celsius. So we expect a very low temperature in degrees Fahrenheit. So we also expect a negative temperature again. And so you have Celsius and you want, let me add an arrow here. Fahrenheit. Oops. Okay, so you want then to use the formula that relates Celsius to Fahrenheit, but Celsius is given, right? Celsius is given. It's the negative because Celsius is given, you want to use the formula that has degrees Fahrenheit isolated, solving for that. So in the document here, you have 3 equations, and the first 2 are relating Celsius to degrees Fahrenheit. And you want, out of these 2, you want to use the equation that says degrees Fahrenheit, outside. Degrees Fahrenheit equals 1.8 times the degrees Celsius plus 32. This way, you will plug in the degrees Celsius and then have your degrees Fahrenheit. So that means you want to use this equation, degrees Fahrenheit, and I wish this was not here yet. So degrees Fahrenheit equals degrees Celsius times 1.8 plus 32. Then you plug in the degrees Celsius, and it's a negative 196 degrees Celsius times 1.8 plus 32. So let's calculate that negative. So the negative sign is important here. In the calculator, it's the negative sign between parentheses. So 196 times 1.8 plus 32. And the calculator answer is negative. Well, let me put that inside. negative 320.8. And that's going to be degrees Fahrenheit. Let me add that. Degrees Fahrenheit. So when you're dealing with temperatures, for rounding, you do not use the additions and multiplications rules. There is a special rule for temperature, and it's the fact that you want to keep the same precision as the initial temperature. And if the initial temperature is given to the one, to the ones like here, or to the degree, you want to keep it, the degrees Fahrenheit, you want to keep them to the degree. So that means you will change this to negative 320, and you will stop there, except that what comes after the 0 is a 8, so the 0 will become a 1. And then you will bring back the degrees Fahrenheit here. So that's what would be the final answer. You want to round it to the ones or to the degree, because the given temperature was, precise to the degree. So that's very important to remember this rule for temperatures. Keep the final temperature to the same precision as the initial temperature. Here to the ones or to the degree. So let's do problem 19. At what temperature does the number of degrees Celsius equals the number of degrees Fahrenheit? So it looks like we will use the same equation because it relates degrees Fahrenheit to degrees Celsius. So let's use the same equation here. And we have this relationship between degrees Fahrenheit and degrees Celsius, and we want to know what is the temperature for which, these two values will be equal. So because they will be equal, we can simply change them to the same variable, and let's call them x, for example. So then if we change degrees Fahrenheit and degrees Celsius by x, and x will be the same, value for both, we'll have the equation will look like this. We will have x is equal x, because degrees Fahrenheit becomes x, is equal to degrees Celsius, which becomes x also, times 1.8 plus 32. And so when we write this more algebraically, it's 1.8x plus 32. If you put the x's together, let's move the 1.8x to the left of the equal sign. So that means you will do negative 1.8x on both sides of the equal sign. So that's going to become x minus 1.8x. And then on the right side, the 1.8x will be cancelled by the negative 1.8x. Now we need to add the 1x plus the negative 1.8, and 1 minus 1.8, it's going to be negative 0.8. So that's the what it looks like now. And now we need to solve for x. So to get x by itself, you will do 32 divided by negative 0.8. And 32, divided by negative 0.8 is, if you do that in your calculator, 32 divided by negative 0.8, it's going to be negative 40. And so x, you remember, we used it as the variable that would be both or degree Celsius and degree Fahrenheit. So that's why x here is equal to negative 40 degrees Fahrenheit or negative 40 degrees Celsius. So that's the temperature at which we have the degrees Fahrenheit matching the degrees Celsius. So let's do the final problem on temperatures. A cake is baked at 350 degrees Fahrenheit. Convert this temperature to degrees Celsius and kelvins. So we need to change degrees Fahrenheit to degrees Celsius and then to kelvins. So let's look at the equations we have. We have degrees Fahrenheit and we want degrees Celsius. So this time we will use this equation, the one that relates, that has the degrees Celsius outside and then the degrees Fahrenheit in the equation, because we have a value for degrees Fahrenheit. So we can plug in the value of degrees Fahrenheit into the equation and calculate degrees Celsius. So let's do that. So the equation looks like this. Degrees Celsius equals degrees Fahrenheit minus 32 over 1.8. So let's plug in the value of degrees Fahrenheit, 350 degrees. So 350 minus 32, and you want to do equal or do that, you need to do the intermediate answer before you do divided by 1.8. Otherwise your value will be wrong. Divided by 1.8. So let me back up here and say 350 minus 32 is 318 divided by, so let's write it down. 318 divided by 1.8, it's going to be equal to 176.666 degrees Celsius. So let's think about how many, how do we run this? Remember, it's written above here. Keep the final temperature to the same precision as the initial temperature, always. And so here the degrees Fahrenheit are given to the ones because there is the dot here making the 0 significant. So it's given to the degree. So again, we want to round to the degree. And here it's going to be rounded 176. The 6 will become a 7 because what comes after the 6 is a 6. So 7 and then degrees Celsius. So that's the temperature in degrees Celsius. Next, you want to convert that to kelvins. And there is no direct relationship, as you can see, between degrees Fahrenheit and kelvins. You have to use degrees Celsius to change to kelvins. So we will use the degrees Celsius and add 273.15 to get the kelvins, right? We will use this equation. So the equation is like this. Kelvins are degrees Celsius plus 273.15. It's so here, if you use the amount that has not been rounded, you would use that. So degrees Celsius, to see where it comes from here. Degrees Celsius plus 273.15 equals. So let's do this in the calculator. 176.666 plus 273.15 equals 449.816, etc. And that's kelvins. So notice how kelvins do not have a degree symbol. Kelvins are written without that little degree symbol. There's no degree symbol for kelvins. It's just capital K. So again, keep the final temperature to the same precision as the initial temperature. So that means here, again, we want to keep it to the degree, to the ones. So here we will need to run to 449, but what comes after the 9 is a 8. So the 9 will have to be rounded up. And so 49 will become 50. And we need to show the dot here to show that the 0 counts. It's a significant digit. So that would be the temperature in kelvins, 450. So we are moving on to densities. That's also part of this, the second part of the chapter 2. 3 liquids have densities of A, 1.15 grams per milliliter, B, 0.79 grams per milliliter, and C, 0.95 grams per milliliter. When the liquid which do not mix are poured into a graduated cylinder, which liquid will sit at the top and which liquid will sit at the bottom. So when you have density values with the same units like that, you can compare them. And here we have the larger value, and that's the smaller value. That's the middle one. So which liquid will sit at the top? It will be the less dense, and the less dense means the one with the smaller value. So actually B here will be the liquid at the bottom. Sorry, at the top. I'm giving the answer to the first question here. It's going to be the liquid at the top because it's the smaller density value. And then which liquid will sit at the bottom? It's going to be the liquid with the larger value of density, right? Larger densities always sit at the bottom, and then smaller densities will sit on top. So that's answering question 21. Let's do question 22. Liposuction is a cosmetic procedure used to remove excess fat from the abdomen, thigh, or buttocks of a patient. If 2.0 liters of fat, and you're given the density of fat, is removed, what is the mass in kilograms of this fat? So what is the given amount here? So the density is always going to be used as a conversion factor, right? Because it's a value with 2 units. It's grams per milliliter. So you can see density as 0.94 grams of fat equals 1 milliliter of fat. That's how you want to read this. So that's the density. And that's not the given amount that you will start the calculation with. The given amount you start the calculation with is going to be the 2 liters of fat here. Because that's a simple unit, a simple measurement. And you want to convert that to kilograms. Want kilograms of fat. So, and the density is what allows you to change the mass into the volume, right? Because density relates mass over volume, right? Grams per milliliter here. And so you have a volume here and you want a mass, right? And so the density will relate the milliliters to grams. But you see, it's milliliters to grams, and we have liters and we want kilograms. So we need to do some conversions around the density, right? Because let's say here we start with liters, and we can change them to milliliters, right? By doing this, we then can use the density and change the milliliters into grams. And once we have the grams, we can change them to kilograms. So that's what the roadmap will look like. So let's gather all the equalities. So we have the density for one of them. We need the liters to milliliters. So you go to this document, liters to milliliters. 1 milliliter is 0.01 liter. So let's write this down. 1 milliliter. It's always 1 milliliter. So 1 goes to the prefixed unit. Here, the prefixed unit is the milliliter, and then the 0.001, and then you bring back the base unit of liters. That will change the liters of fat to milliliters. Then we use the density to change the milliliters to grams. And then we need to change the grams to kilograms. And here, 1 kilogram is equal to 1,000 grams. So let's write this down. 1, and you see here the prefixed unit is the kilogram. So you give it the 1 kilogram, and you change the kilo by its value of 1,000, and you bring back the base unit of gram. So we are ready to do the calculation. let's make this bigger. So always start the given, always start the calculation with the given amount on top here. So we start the given amount with the, sorry, we start the calculation with the given amount in the numerator. And so 2.0 liters, that's large, of fat here. So 2.0 liters of fat goes there. And it's a simple measurement here, liters of fat. It's a volume of fat. So nothing goes in the denominator. So you can put a 1 in the denominator. You will multiply by 3 conversion factors, right? We have 3 arrows, so 3 conversion factors. The first conversion factor needs to cancel the liters and change the liters to milliliters, right? Liters to milliliters. So we will use this, and on the bottom, it's going to be 0.001 liter is equal to 1 milliliter, and that goes on top. So this way, liters cancel, and you're left with milliliters. The next step, you want to cancel milliliters. So in the next step, you want milliliters in the denominator. And here it comes from the density that says you have 0.94 grams of fat, per milliliter of fat. So this way the milliliters cancel, you're left with grams of fat. Next step, you want to change the grams of fat to kilograms. And so you will use the fact that 1 kilogram is 1,000 grams. You want to cancel grams, so you will place the 1,000 grams on the bottom and then the 1 kilogram on top. We can see here how, liters cancel, milliliters cancel, grams cancel, and then we're left with kilograms. So that's what we want. In the calculator, you do 2.0 times 1 milliliter times 1 times 0.94 grams times 1, and then divided by every denominator that is meaningful. So 0.001 and divided again by 1,000. Actually, these two will cancel out, and it's 1.88 kilograms. So that's the calculator answer. Now we need to pay attention to the number of sig figs. We have 2 sig figs in the given amount of 2 liters. Remember how, by definition, 1 milliliter is 0.001 liter, and that's the exact. It does not limit the number of sig figs. Same with the kilogram and the 1,000 grams. These are exact. Do not limit the number of sig figs. 1 milliliter here for the density is exact, but the 0.94 is measured. So, and we have 2 sig figs there, the 9, the 4. So we have 2 sig figs in the both given measurements here. So we need to keep 2 sig figs, and it's 1.8. What comes after the 8 is another 8. So the 8 has to be rounded up to a 9, and then kilograms. And that's it. That's what 2 liters of fat will be. It's 1.9 kilograms. So slightly less in mass, because the density is slightly less, in mass than per unit of volume.